Next problem I'm going to be doing is chapter 16, problem number 10. It basically states, the jet skier is moving at 8.4 meters per second in the direction in which the waves on the lake are moving. Each time he passes over a crest, he feels a bump. The bumping frequency is 1.2 hertz, and the crests are separated by 5.8 meters. What is the wave speed? So this problem basically deals with relativity, and so basically, once again, what you do is you write down the things that you are given in the problem. It's always important to write down what you're given. That way, you'll be able to adequately know what you're trying to find. So you are given the jet skier's velocity, which is 8.4 meters per second, the bumping frequency, which is 1.2 hertz, the crest separation, which is basically the wavelength, which is 5.8 meters. And what they're trying to have you find is the wave speed. So you're trying to find the velocity of the speed. So just a couple of notes to point out. The jet ski, you want to find out the jet ski. You want to understand first that the jet skier and the waves, they are moving in the same direction. But although they are moving in the same direction, they are not moving at the same velocity. We know the velocity of the jet skier, but we do not know the velocity of the wave. We know that the jet skier is having a faster velocity than the wave. So basically, we know that right now we are given the jet skier's relativity compared to the shore. So with that, we're going to use the velocity of the jet skier and shore equals the velocity of the jet skier and the wave plus the velocity of the wave and the shore. Because we know for a fact that the jet skier is moving faster than the wave, we're going to use this equation. We're going to have to subtract it. We're going to have to subtract the velocity of the jet skier minus the jet skier with the shore minus the velocity of the wave to the shore. So basically, this problem does a lot with relativity. So the next thing you will want to do after that, you know that velocity is equal to frequency times wavelength. So basically, you're going to substitute this equation, which is in the book 16.2. You can look at it, chapter 16. You're going to substitute this equation into this equation right here for the relativity of the velocity from the jet and the wave. So that would then be frequency times the wavelength equals the velocity of the jet skier and shore with the relativity of the velocity from the wave to the shore. So the next thing you want to do is plug in the information that we were given. We know the frequency which they gave us, which was 1.2 hertz. We know the wavelength what they gave us, which was 5.8 meters, which equals the velocity of relativity from the jet skier to the shore, which we were given 8.4 meters per second. And what we're trying to find is the velocity from the wave, the velocity of the wave to the shore. So basically, after that, you're going to put in all your equations, as you can see right here. Put in all your equation, and you're going to solve for the velocity of the wave. So to solve it, you're going to times 1.2 hertz times 5.8 meters minus 8.4 meters per second. That will equal the negative velocity of the wave. So in order to get the positive velocity of the wave, you're going to times everything minus -1. And in the end, your answer should be 1.4 meters per second. So 1.4